Hello. In this video, we're going to cover queues, so the solutions for the exercises from the queue lecture, which hopefully you will have attended, so you know what queues are before we begin. If you haven't, review the notes so that you understand how the queues work, and I'm just going to focus on the solutions for the code. Now, let's start by rebuilding our node structure and everything. So we're going to do all this in Python Tutor, so again, we can see what's going on. So just setting everything up here, we need our good friends IO stream, we need our namespace, and we need our node structure, which is going to have data and a pointer to the next node. Okay, nice and quick. Now, with that node structure, we're going to make a queue class that has two node pointer variables, front and back. We'll keep this simple and we'll make everything public for this, but you probably should not do so if you're doing this properly. You should use getter and setter methods. Maybe we'll actually do it properly. I think that's a better idea. Sure. Class queue. So a queue class is going to have a node pointer to the front and a node pointer to the back. And publicly, we're going to have a constructor. What else do we need to have? It defaults both of these to null. An isEmpty function returns true if the queue is empty. Okay, that's easy enough. So we need bool is empty, which is again a one-line function. We can write this really quick because it's just going to return if the front is null. If the front of the queue is null, there's nothing there. So obviously if the front is null, then the queue is empty. Now, we also need, to build our constructor, and we also want to have get methods. So we want to have node pointer get front, which is just going to return front, and we'll do get back as well. Okay, just to build our constructor, we'll make a queue function, and all it will do is it will set our front to be null and our back to be null. And when we handle modifying our queue in certain ways, we'll make sure that if the queue is empty, these will always both be null. There'll never be a case where one of them is null and the other one is not, otherwise something weird is going on. Okay, we have made our functions, and I think everything here is good. Does this compile, just to be sure? Shouldn't really do anything, but... new types may not be defined in a return type. Did I forget to put a semicolon here? Yeah, I just forgot a semicolon. No big deal. Okay, first exercise. Let's go on to the second one. So, next exercise. Implement the enqueue function for a queue. All right, so you should review how enqueue works. I'm just going to handle the solution. You should always try doing these coding exercises before you look at the answers. So enqueue is void because we don't actually return anything, but we do need to take a node that we're going to enqueue. Let's write this function. So void the queue function enqueue given a node needs to insert that node into the queue. So let's, again, think a little bit before we actually go ahead and code everything. And we should consider first the empty case, which means if the queue is empty, this is the front and the back. So if is empty, then this code is really simple. Front equals the address of n, back equals the address of n, and then I will return. That's it, done. You don't have to do anything else. If, however, it's not empty, then I have to consider, okay, so I have at least one node, so front and back are both not null. If I want to enqueue something, well, let's think about this for a second. So I have a lineup, and I'm adding something to the lineup. That means that whatever's at the front should not change. It's still at the front of the queue, even if I go add myself to the back of the queue, but the back of the queue is going to need to change. So the back of the queue must become this new node n. And in addition, I need to make sure that what was at the back is now in front of the new node n. And I need to make sure I do this in the right order. So in front of n must be the old back of the queue. And I'm going to do it in this order to keep it simple. If I do it the other way, my issue is that changing the back of the queue, that means I lose the person who was there, and I don't want that to be the case. I'm thinking persons because I'm thinking of a lineup of people, because that's usually where you would find a queue. Okay, in front of n must be the old back of the queue. So that means n dot next has to be the back. Not too hard. And now the back of the queue must become this new node n. So the back is now n. And then we're done. So just to make sure this works, let's build a queue. Queue. And we're going to make some nodes. Node n1 is a node. Node n2, n3. Just like last time, we'll make them 7, 8, and 9. So n1.data equals 7, n2, n3, 8, 9. And we'll do q.nq, n1, and q.nq, n2. Now this is going to make copies of nodes n1 and n2. You might not want to do that. Maybe you want to actually put these nodes specifically in which case you can decide, does it make more sense to actually have this as a pass by reference function? I think we will, just for the sake of keeping the thing from getting too cluttered. But it could be the case that you want to make a brand new node to put in. We'll use pass by reference so to keep it easy. Sorry, I did mean NQ with a capital E. I should probably not make it a capital E. That's not, I think, good style. Functions should usually start with a lowercase letter. Okay, so we have our queue. Our queue has a pointer to the front and a pointer to the back. At the beginning, there's nothing there, so this is going to just be set up to null. And our nodes are going to start by pointing to nothing and have no data, but we'll fill them with 7, 8, and 9, just like we did last exercise. And we're going to NQ n, n1. So these pointers here, this, the word this, meaning the queue that is running the code, is Q, the letter Q. So my queue is trying to NQ this the node n1. I shouldn't use this. This gets confusing. So my queue is empty. So to do what I need to do, I need to set the front to be n1 because that's the front. So this white arrow you can see here points to the front. The back is also going to be the same thing because my queue only has one thing in it, and then we're done. Okay, so my queue right now is just n1. There's nothing else there. It has no pointer or anything because it's at the front. It doesn't need any pointers. When I queue n2, n2 should go behind n1. So the front of my queue should still be n1, but the back of my queue should be n2. Now, to do this, I check, is it empty? It's not empty. So the next node after n2 should be n1. So this pointer null down here should change. Now it points to n1 because n1 comes after it in the queue, or it comes before it in the queue. The back of the queue, which was n1, should now be n2 because that's the back. And then we're done. So what are we left with? This is kind of messy because this arrow is overlapping. Let me highlight it in red. So you can see the red arrow here is the back of the queue. The back of the queue is n1. After so n1 is at the back, and then in front of n2 is at the back, and in front of n2 is n1. And then there's nothing in front of n1 because it's at the front. And now you can NQ as many nodes as you want, and it will always keep track of n1 being the front of the queue, and we can put more stuff at the back as we like. Okay, not too bad. Let's move on to the next exercise. So, implement DQ for a queue. Not too hard. Let's go through it. So, DQ is going to give us back a we'll go with a node pointer. Again, you could do a node or a node pointer. It's kind of depends on how you want to implement it. We'll go with a node pointer, DQ. And so DQ will take the front node off of my queue, make it so that the new front of the queue is what was behind it, and then that will be it. Now, this is actually a little trickier than NQ, because NQ I made real simple since everything is pointing to the nodes in front of it. Actually, I wonder if I want to do it the other way. If I want to have the next node be the, yeah, you know what? I have my arrows pointing the wrong way. We're going to fix this. So, let's change our next, because when you think about, what's the next thing in the queue, it's not the thing in front of you, it's the thing behind you, right? So let's change what we've done here, and we're going to make it so that the instead of every node pointing to the one in front of it in the line, we'll have everything pointing to what's behind it in the line. So in order to do this, all we have to do is just change this line of code here, which means back next is the address of n. Yeah, so instead of what we have here, this is still true. In front of n must be the old back of the queue, i.e. behind the old back of the queue should be n, the new node. Let's just see how this works before I go on to do DQ, because the way that I had my arrows pointing with DQ made everything very, very tricky to do, but this should make it actually a lot cleaner. So I just switched this one line of code to change where the arrows are pointing. So let's see how this manifests when we run everything. So we set up all of our stuff, 7, 8, 9. Okay, when we NQ our first node, nothing really changes, right? Our first node is N1, it doesn't point to anything, it's done. When I NQ N2, here's what we'll do. Instead of what we had before where you pointed at the thing in front of you, we're only going to have something point to what's behind you, which means N1, which doesn't point to anything, is now going to point to the one behind it and say, hey, this one's after me in the queue. So the queue is not empty. I'm going to make N1 point to N2. Boop, there we go. So now this arrow points to N2, and the back of the queue is now N2. So what we're left with when we're done is this. The front of the queue is N1, the back of the queue is N2, and N1 will point to the queue behind it. It's very important to make this change because the way that I had things going, dequeuing is going to be very hard and a painful process. By making it so that everything points to... sorry about the noise. By making sure everything points to the thing behind, it means that when I remove stuff from the front of the queue, I can quickly update the new front of the queue to be the immediate predecessor. So now that we've got our NQ working, a lot of pop-ups today. Sorry about that. Okay. DQ. Let's write our DQ function. Node pointer DQ. It's going to give us a pointer to a node. So what do we need to do? First off, if the queue is empty, can't DQ. So if is empty, we'll output can't DQ and return null. And I think we'll just for the sake of trying things out, run our q.DQ here to make sure that works. So we DQ before we've NQ'd anything. Our queue is empty. Shouldn't be able to do anything useful. Is empty was not defined because I forgot to write q::: here. Okay. So set everything up, 789 and so on, and then I try to DQ. When I try to DQ, the queue is empty, so I output can't DQ, and then nothing is returned. All right, as desired. Okay, now let's make this work if the queue is not empty. So if the queue is not empty, what do I need to do? I need to grab a pointer to the front node, because that's what I'm going to return later. Change the front of the queue to be the next in line, and then return the removed node. So let's do these one at a time. I need to grab a pointer to the front node to return later. So node, result is going to be the front of the queue. the new front of the queue is going to be the next one after it, and I'm just going to return the result. So DQ here won't do anything, but if we NQ these two, and then we try to DQ and print out the result, let's see if that works. So we'll output DQing result, and so we'll do q.dq data. Sorry, arrow data, because we're getting a pointer back from our DQ, which then should have data associated with it. So we should get the result of DQing our first node, N1, and getting the 7 from it. Let's see if that works. Okay. So set everything up, 789. We're going to NQ N1, NQ N2. So if we do this correctly, we have N2 is at the back, N1 is at the front of the line, and N2 is right after N1. So when I DQ, let's see what happens. It's not empty. So the front of the queue was N1. It's now going to be N2. We're going to have a result which holds on to N1. Now the front of the queue is N2, which is the red arrow. And we're going to return the result, which is N1. And we're going to grab the data from that, and the data from that is going to be 7. And when we look at what the queue looks like now, N1 still points to N2 because that node still exists somewhere in the computer, but our queue doesn't actually consider N1 to exist anymore. It's not actually known. We see that the front and the back of our queue is N2, but there's one more thing we need to think about. Let's try DQing again. Hold up. So we run through everything, 789, NQ N1, NQ N2, so we got our queue set up. We DQ the N1, so we get a 7. We try to DQ N2, let's see what happens after that. So we DQ N2, the result is going to be N2. The front of the queue is now going to be null because now there's nothing there. And we're going to return our result, which has the value of 8, which you want to print out. Something a little weird has happened here, which is you'll notice that the front of the queue is nothing and the back of the queue is N2. That's not quite right, is it? So we need to consider that once the queue has emptied out, what's the back of the queue is now gone as well, and our queue is disappeared. Well, our code, some of our code will still work. You know, our is empty. Obviously, only checks to see if the front is null, and your queue should be empty. But if we tried to, let's say we wanted to NQ something, actually I think this would still work, right? Yeah. So it's a little messy. I mean, I guess it could be better. You could make it so that the DQ checks to see if the queue is now empty and updates the back pointer, but it looks like if we NQ something, it should still work. Let's give it a try. We're going to NQ N3 after. So we have N1 shows up first, N2 comes behind it, we'll process N1 so it gets out of there, process N2 so it gets out of there, and then we'll add N3 and see what it looks like. So skipping ahead, DQing, we got the 7 is out of there, the 8 is out, and now we'll NQ N3. What does this look like? Well, the queue is empty, right? Or at least it should be, because we put in N1, and we put in N2, and then we remove 2 things, so there should be nothing left. It looks like it is empty because the front is null, so we update the front to be N3, the new thing we're adding in, and we update the back to also be N3, and then we return. And now if we ignore the arrow down over here, this red one, we see that our queue just has the front and the back are N3, which is exactly what we want. So it looks like our code is correct. Even though this pointer is a little mischievous sometimes when we empty out our queue, all of our functions, importantly, still do exactly what we need them to do. And that's what is most important for these kinds of data structures. So that's that exercise. I think we have one more before we wrap it up. Okay. Write a toString function for the queue class that prints the queue's content from back to front in the following format. So here's the back of our queue is Huey. Then after that, or sorry, this should be the from back to front. So Huey is Louis is in front, Dewey is behind that, and Huey is behind that. So we want our toString function to go through all of our nodes and figure out how to construct this string. Right now we have 7, 8, and 9 instead of Huey, Dewey, Louie, but we still should be able to figure out how to print them in the right order. So we're not going to dequeue anything. We're just going to enqueue N1, N2, N3 and try to print them out in order. And now let's make a toString function that does that. So string toString, is that what I called it? toString with a capital S. No parameters are needed. toString returns a string. So we have a string result which starts with nothing, and our goal is we need to modify this string over time so that it can contain all of the information we need it to contain. Now we will need to convert our data into strings. Let's double check if that will work okay. I don't quite remember if I'm allowed to do this, so I'm going to use Python tutor to just check it out. Actually, you know what? I'll use my online GDB to do it real quickly. So all I want to do is, first off, I want to include string, otherwise, I'm missing some stuff that I could have. So let's include string in both of our programs. And over here, I want to verify, can I do something like this? My string is empty, string, or my string plus equals, let's say if I do 7, and output my string. Beep. Should disable the sound over here, huh? Okay, that didn't quite do what I wanted it to do, which means I need to figure out how to do what I want. So I think I can use toString for this. toString. There we go. Okay, so this is what I need, is I need to be able to use toString to combine a bunch of strings together. So I'm going to have to convert the numbers into strings so that I can mash them up. Now, I want to print out everything from the... so in order, I want to have everything in the back of the queue is supposed to be on the left side, and everything in the front is going to be on the front side. But I want to start, because all my arrows, my pointers are actually pointing the opposite direction. I need to make sure that I can figure out how to handle that problem. So here's what I'm going to do, is I'm going to, first off, I'm going to need a pointer that's going to point to every node of my queue one at a time. So we're going to have a node pointer, current node, is going to start at the front. And while the current node is not null, I'm going to keep building up my string. So, first things first is I want my result to be equal to what it was, but I want to put in, on the left side of it, the, bracket, what was the format I need for this? Bracket plus bracket, and inside here I want toString current node data. So what this should do is it should take, and let's put a space in there as well. We're actually supposed to have an arrow, I think, right? Have an arrow, something like this. Our results should be, so whatever node we're on, we want to add an opening and closing bracket. We want to have the data there, and we want to put a little arrow in front, and we want to say, okay, that's our result. Then we move our current node to be the next one. And when we're done, we return the result. Let's see what this looks like. So we're going to enqueue 7, 8, and 9, and then we're going to try to do queue output queue dot to string. So we'll skip to, okay, we got our queue built. Oh, okay. And now we're going to try to make our result. And what's our result going to look like? Okay, we got some problems here. So first off, the front of our queue is 7, which appears in the right spot. That's good. There's an extra arrow at the end. That's not good. And there should be a space after this bracket. So we need to fix those things. But we have we're on the right approach, right? We're almost there, actually. We have most of what we're looking for, but we need to fix the formatting a little bit. So here's what we're currently working with. Currently we have this. So to fix this, first off, we want to make sure that there's actually a space after this arrow. And second of all, we have the issue that that an extra arrow is being added at the beginning of it, which we don't really want, because we want to make sure that when we hit the last thing, we don't put in this extra arrow. So we can actually just write one little extra piece of code to handle that, which is if the current node is the back of the list, there's no more to add. So current node next is null. Then we're going to do it slightly differently. We're going to take this, but instead of adding an arrow to the front, we're just going to put the string itself. I think we're going to be a little off. We're not going to be quite right. But I want to see what this looks like, and then we can fix it from there. Always a good practice to, even if you don't have the perfect solution right away, which you probably never will, try things out and see what happens, and that can help you figure out the right solution. So here's our attempt, is if we're at the back node, then we should not add the extra arrow in front. Otherwise, we keep adding the arrows. Now, let's try this again and see what happens. Just going to skip to the end and see what we get. So what are we given? 9. Well, how about that? Pretty convenient, huh? So just to recap what we did for our toString function. We start with an empty string, and we're going to populate it with the information we need. We're going to start from the front, and what we're actually going to do is we're going to make sure that we are putting the string that we've built so far on the right side of everything, and anytime that we make a new node, anytime we get a new node to print out, we're going to put that message on the left. So that way we can always be adding things to the left of our string over and over until we've filled it out. We're always going to put in an arrow after each node until we reach the one at the end. The one at the end doesn't need to have another arrow after it like this. We just want that with the spaces. And then hooray, we have exactly what we were looking for, which is great. And that should be everything for our queue. It's a little lengthy piece of code, but it's worth practicing how to do all these things and how to figure them out, because that makes you a better coder. So give it a shot. And thanks for watching. See ya.